Hi, I'm Sant Ranjan from KPIT Technologies, and today I will like to discuss some of the areas onto the thermodynamics, or we call it heat or thermal management, relevant to our mobility areas. So one thing I just want to start with, that right from very first engine being made, if you remember, with the James Watt engine, the thing started with heat converting into mechanical energy, and the first automobile also was built based on the steam engine. So that steam engine till today, even when we talk of the electric vehicles or the fuel cell vehicles, heat is continuously there in any of the system. So when we talk of the steam engines, we have to generate the heat to produce the motion. Now when we talk of internal combustion engines, we were generating heat using the fuel, which was converting into mechanical energy. Now when we are not thinking of the fuel cell engines or the fossil fuels or your steam operated engines, still we have heat which we need to manage. That is in the form of the heat which is coming out from the battery when the battery operates, coming out from the motor when the motor operates, and coming out of the power electronics components in case of the electrical vehicles. Then when we talk of the fuel cell engine, there is a huge amount of heat which is getting wasted from the fuel cell. So now the question remains that we move as far as into the mobility areas, or we develop very latest class of vehicles, heat management or the thermal management has to be there. Still, I am talking of the areas which are linked to heat converting into motion or heat produced due to motion. One more area is there, which is the comfort air conditioning. That is also part of thermal management system, which is also extremely important in the car. So if you see that there are huge areas relevant to the thermodynamics and the heat management system in the car. So when we talk of that, what are the different areas of improvement, or the areas which are relevant to innovation or the ideas, I can see each and every portion where heat is either getting used or heat is getting produced. We have enough number of areas we can work upon the innovation to optimally use the heat. So the heat is not wasted much, and whatever heat we are producing, it is used in a innovative manner. Now, one example I want to give, that there in air conditioning, what when we talk of the comfort air conditioning in the bus or the car, there are many systems which can be run out of the waste heat. Like one example is your vapor absorption system, which runs on the waste heat itself. So is there any area we can use the heat produced by the engine or the other parts of the vehicle for cooling of the bus or the car, or we can use we can produce the cooling by using that heat for the portion of the vehicle which are producing actually heat. So these are the many areas, and you know that energy is constant. So when energy is constant, we say that either the energy neither created nor destroyed. So in this is also one of the area, in my personal opinion, we have to work a lot so that we don't waste energy, which is impossible as per the Carnot cycle. But we have to minimize it, and there are many options and innovations possible in that area. And I will request all the innovative thinking students and the engineers to participate in our competition, which is called KPIT Sparkle, where we have a lot of opportunities given for the energy and mobility, where you can put your ideas, you can submit your thought processes, and you can collaborate with the other teams to work on this area. So I just spoke on the thermal area. There are many other areas which you can contribute a lot for this competition. Thank you very much. Bye.